Let's talk about vectors. First, vectors are quantities that have both a direction and a magnitude. As an example, for position, the magnitude is going to be a distance in meters, and the direction is going to be given in terms of angles. Okay, let's digress a little bit. In physics, we deal with two basic types of quantities. Scalars. These are quantities which have just magnitudes and sign, but no direction. Examples of such quantities are mass, volume, temperature, time, etc. Now, not all of them have positive and negative sign. For example, temperature, if we use it in Kelvin, is going to be always positive. But then, if it is in centigrade, it has negative and positive values. Volume is always positive, etc. Now, the magnitude, the word magnitude is referring to the amount for that particular quantity. When we say mass, how many grams is the magnitude? How many meter cubed would be the magnitude of the volume? How many degrees is going to be the magnitude of the temperature? Vectors, on the other hand, are physical quantities that have both a magnitude and a direction. So they have an amount, very much like scalars. But along with that amount, they will have a direction. Examples of vectors are position, displacement, velocity, acceleration, force, torque, etc. Notice here terms that you are familiar with in terms of motion, like distance and speed, are not in here. They are not vectors. How do we represent a vector? In a diagram, graphically, we represent it by an arrow like this one here. The length of the arrow is a measure of the magnitude. The direction along which it's pointing is the direction of our vector. That's the way we represent a vector graphically. If this was pointing at a different direction, like this way, okay, let me draw one. For example, this one is a vector pointing in that direction. This one is a vector pointing in another direction, etc. Now, in terms of symbols, we use usually a letter and put an arrow on top of it, like here. That's vector A. In books, sometimes they use boldface, non-italic boldface to represent vectors. Personally, I prefer this notation. Now, when we talk of the magnitude, like in this particular case, the length of the arrow tells us what the magnitude is. So according to the scale, the length of the arrow is 3, so our magnitude is 3. Let's pull in this, some simulations. Okay, this is the simulation linked. The vector fun simulation. When you load it, it should show up like this, and then we can get it to show us 2 vectors, 3 vectors, up to 6 vectors. Okay, notice here, these vectors, they point in different directions. These are the arrows we are talking about, and we can tell it to show us the magnitudes. This is the magnitude of the vectors. For example, this is 374, this is 374. So these 2 vectors, they look like they have the same magnitude and the same direction as well. This one, it looks like it's a little smaller, but it also has a different direction. This is quite a bit smaller, and so on. So that's the magnitude of the vector, the length of the arrow. The direction is given by the way the arrow is pointing. So the angle we usually measure it relative to the positive x direction, the eastward direction, in the counterclockwise direction. So we rotate counterclockwise. For example, this particular one drawn here is 31 degrees north of east, or 31 degrees relative to the x-axis. Okay, going back to our simulation. Okay, let me hide the magnitude. You look at the angles here. For example, this one is 34 degrees relative to the positive x. So if I put it here on the coordinate frames, that's our 34 degrees. Now for the second one, this one, lo and behold, it is also the same direction, 34 degrees. Now let me take the third one, same direction. Let's take, I believe, this is the fourth one. Look at the angle it gives us, 338.20. The angle is measured relative to the positive x direction. Here is the positive x direction, the way that bluish arrow is pointing. You have plus x here. So we go counterclockwise till we get to our vector. Counterclockwise is just like this. So we go from here all the way here. That's the 338. It is any vector that falls in the fourth quadrant is going to have a direction given in terms of angles that go from 270 to 360. Now, this particular vector falls in the third quadrant. In this case, the angle has to be between 180 and 270. In this particular case, 208. That's again relative to the positive x. And last, this vector here, the gray one, vector f, the angle is relative to the positive x, is again 158.20 in this case, and it should fall between 90 degrees and 180 degrees. Now, how do we represent vectors? Okay, we use a symbol and put an arrow on it. But also, since a vector is given by a magnitude and a direction, we can represent it by just providing in parentheses a magnitude and the angle for direction. By the way, so far I showed only vectors in 2 dimensions on a plane, where we have x-y axis. If we were to deal with vectors in 3 dimensions, which we will rarely do in this course, then instead of just one angle, we'll have to have 2 angles to give a complete description of the direction. Here for 2 dimensions, it's just one angle. Also in terms of notation, for the magnitude, we usually put like the absolute value sign around the vector. So this tells us it's the magnitude of vector A. A by itself, or this vector A between the absolute value symbols gives us the magnitude of vector.